All right, welcome. Today, we're diving into one of the biggest headaches in data engineering. What do you do when your company's growth goes through the roof and your systems just can't keep up? We're going to look at how on-demand cloud computing is the perfect answer, and we'll break it down with a real-world example. Okay, let's get into it. So picture this. You're a data engineer at a food delivery company we'll call Hungry Now. And business is, well, it's exploding. You're now processing a mind-boggling 150,000 orders every single week. Now, for the CEO, that's amazing news. But for you, that number is a huge flashing red light. Because with that kind of scale, a whole mess of problems comes along for the ride. You've got these insane spikes in real-time data right around dinner time. You're constantly integrating with third-party APIs like Google Maps for driver tracking. And the business is demanding real-time dashboards that absolutely cannot go down. Your old system, the one you built back in the day, it just wasn't designed for this. It's creaking, it's groaning, and it's about to fall over. Now, this is what we in the business call a good problem to have. The company is succeeding so much that it's actually breaking the technology that got it there. So the big question is, how do you fix it? How do you architect a system that can not only handle today's pizza rush, but whatever comes next year and the year after that? Well, the answer, my friends, is in the cloud. More specifically, it's in an on-demand model. And this is a total game changer. It means you can build a system that automatically beefs itself up to handle that massive Friday night demand, and then, just as important, scales right back down when things are quiet on a Tuesday morning. You only pay for what you use. So what is on-demand cloud computing, really? Well, simply put, it's a pay-as-you-go model offered by the big players. Microsoft Azure, Amazon's AWS, Google Cloud. You're basically renting their massive computer infrastructure, all the storage, the databases, the processing power you could ever need, and you only pay for the exact amount you use, when you use it. It means no more buying super expensive servers that just end up collecting dust most of the week. Now, once you decide to move to the cloud, you've got a pretty fundamental choice to make. You can go with a public cloud, like Azure. It's built on shared resources, which makes it super cheap, incredibly scalable, and really fast to get started. Or you could build your own private cloud. This gives you way more control and is great for super sensitive data, but man, is it expensive and complicated to manage. But there's a third way, the hybrid model, and this is usually the sweet spot. This is where Hungry Now makes a really smart move. For most of their operations, they use the public cloud to get that amazing scale and cost efficiency. But for handling sensitive credit card information, they use a private, super secure system to meet strict compliance rules like PCI DSS. They're really getting the best of both worlds. Okay, so we get the why now. We understand the strategy. But let's dig into the how. What are the actual tools, the building blocks that a data engineer gets to play with on a platform like Azure? Think of it like a massive toolbox. For that real-time GPS data coming from delivery drivers, you'd grab a streaming tool like Azure Event Hubs. Need a place to dump all your raw data, like images of receipts? That's what Blob storage is for. It's cheap and massive. Need to automate a small task, like sending a text when an order is delivered? A serverless function is perfect for that. Every tool is designed for a very specific job. All right, so we have our toolkit full of shiny new services. Now, let's put on our data engineer hat and actually assemble these pieces into a working, scalable solution for Hungry Now. So here's how the data makes its journey. Step 1, all that live data from driver apps and customer orders gets ingested in real time using Event Hubs. Step 2, that raw, messy data, receipts, logs, you name it, gets dumped into Blob storage. Step 3, Azure Data Factory comes in like a foreman, kicking off jobs to clean and transform that data on a set schedule. Step 4, the nice, clean, structured data gets loaded into a proper SQL database for easy analysis. And finally, Step 5, the business folks can slice and dice all that data in their Power BI dashboards, from chaos to clarity. Now, here's a really crucial point. We're using Azure in this example, but these ideas are totally universal. It doesn't matter if you're Team Azure, Team AWS, or Team GCP. You're going to find the same types of tools everywhere. AWS has Kinesis for streaming instead of Event Hubs, and Glue for orchestration instead of Data Factory. The names are different, but the jobs they do, they're pretty much the same. Your skills are transferable. Okay, so building the system is one thing, but now you have to run it, maintain it, and keep it from costing a fortune. And this is where a good data engineer becomes a great one, by constantly balancing a few critical trade-offs. And these are the big four. You are always playing this juggling act. You want high performance, but that costs money. You want to move fast, but you can't compromise on security. You need to keep everything compliant. Every single choice you make as an engineer is going to affect these 4 areas. Let's talk cost, because that's always a big one. You can be really clever about this. Use auto-scaling so you're not paying for a massive system at 3 a.m. Set up rules to automatically move old, rarely used data from expensive hot storage to super cheap archive storage. Use those serverless functions for tiny jobs instead of paying for a server to be on 24/7. These little levers can save you an absolute fortune. And then there's security. This is the one area that is completely non-negotiable. 2 practices are absolutely fundamental here. First, role-based access control, or RBAC. It just means people can only access the data they're actually supposed to see. Plain and simple. Second, you use a secure vault like Azure Key Vault to manage all your passwords and API keys. You never, ever hard code them into your scripts. So, let's bring this all home. It's fantastic to know all this technical stuff, but how do you actually talk about it? How do you put it on your resume or explain it in a job interview to prove you've got these valuable skills? Look at this sentence. This is pure gold. This is the kind of language that makes hiring managers sit up and pay attention. Let's break it down. You state the business problem, unpredictable demand. You say what you did and what tool you used, implemented using Azure Event Hubs. And then, the most important part, you give them a measurable result. Reduced cost by 35%. Problem, action, result. That's the magic formula. Because at the end of the day, it all comes down to the metrics. You can't just walk in and say, yeah, I made things better. You have to prove it with cold, hard numbers. How much money did you save? How much faster are the reports now? What's the system's uptime? You need to show your work. So if there's one thing you take away from all this, it's this. A modern data engineer doesn't just know how to click the buttons in Azure or AWS. A modern data engineer can clearly explain why they chose one service over another. They can articulate how their solution balanced those critical trade-offs of cost, security, and performance. That's the real skill. Which leaves us with one final thought to chew on. Imagine your boss comes to you with a project that has an impossibly tight deadline. What's the first trade-off you're willing to make to get it done? Are you going to throw more money at it? Are you going to accept a slower, less performant solution? Or maybe build something that works but is a bit messy? There's no single right answer here, but thinking through that question, well, that's what being an engineer is all about.